Well, when we were talking about isotopes, one of the things we didn't address was the whole area of carbon-14. I mean, most people are familiar, and yet I'm not sure we know exactly what that is. Can you describe that?
Well, first of all, we need to clear up a confusion. Most people think that radiocarbon has been used to date rocks. Whenever they think of radioactive dating, they think of radiocarbon because that's what they're used to hearing. But radiocarbon isn't used to date rocks because most rocks don't have carbon in them. And what we need is organic carbon because it's intrinsic to the methodology or how you understand how radiocarbon works.
How does a tree then get carbon-14 in it?
Well, it's simple because the radiocarbon is produced in the upper atmosphere. Cosmic rays bombarding the Earth's atmosphere turns nitrogen atoms into carbon-14 atoms, which circulates into the carbon dioxide that we breathe. Mm-hmm. And so it's also taken in by the plants during photosynthesis. So it's in the wood, it's in the leaves, it's in the vegetables we eat. Animals take it into their bodies, so it's in the animals that we eat. So it gets into our bodies. So not only are all these plants around us radioactive with radiocarbon, but we are ourselves.
So you have it, I have it.
Correct. And as long as we live, we're taking more radiocarbon into our bodies. But when we die, we stop taking radiocarbon into our bodies. And so a dinosaur dies, it stops taking in radiocarbon, and then over the thousands of years, it's getting less and less radiocarbon. And as I said before, after 90,000 years, there should be no radiocarbon left in dinosaur bones. If every atom of the Earth was radiocarbon, it all would have decayed away in less than 1 million years. So if you already believe the fossils, dinosaur fossils, the coal beds, all those things are millions of years old, you wouldn't expect to find any radiocarbon in them. And yet you do. And this is one of the things that we found when we studied petrified wood like this at different levels in the geologic record. I was doing research on this. I was collecting samples in England, in Australia, and I sent them to radiocarbon laboratories, and sure enough, they had radiocarbon in them. So this is another aspect of this whole time question, because if these things are believed to be millions of years old, like this petrified wood, and yet it has radiocarbon in it that says it's only thousands of years old, then it means that it calls into question the conventional time frame. And so we wanted to test this because we'd seen in the literature, this is in the conventional literature. In the 1980s, they developed a new methodology for measuring radiocarbon. They could count atoms of radiocarbon. That's how good it was. But they wanted to be sure that they weren't getting any contamination in their laboratories. And so they took samples like petrified wood, they took samples of dinosaur bones and coal and oil and natural gas and limestone even, and they put them in their equipment, and every sample they tested had radiocarbon in it. And this was reported in the literature, and they ignored it. So in our research, we decided, well, we'll test that for ourselves. We wanted to be sure that this wasn't an artifact of the conventional experimental method. So we selected samples from 10 different coal beds around the United States, some coal beds that were conventionally as young as 40 million years, some coal beds that were conventionally over 300 million years old. And when we tested them for radiocarbon, they had radiocarbon in them, and they all yielded the same radiocarbon age, which meant that these plants must have all lived at the same time and died at the same time. And that fits the flood paradigm because these would have been pre-flood trees that were all buried together at the same time.